I'd like everyone to welcome Isaac Shapira to the stage. He says he's much more fun off stage than he is on stage, so to catch up with him sometime after the talk, please welcome Isaac Shapira.
You bask in your glory. Okay, so who was here for my talk last year? That types are not safe. Okay, so if you remember that at all, I unleashed sort of a screed against type systems and that they have diminishing returns at some point. And a lot of people ask me like, well, what do you suggest then as an alternative, given that we know that tests are not really sufficient in a lot of ways? And this is a project that kind of started as a journey for me about 10 years ago when I first attended LambdaConf and started doing functional programming, and it's been a lot of kind of distilling things down. We're going to get started here. All right, so this is the programming power paradox. What is programming power? I need to convince you of three things. Number one, compilers and applications present a paradox. Okay? Number two, automation is limited by the language, the host language. I'm going to use this term a bunch. When I say host language, I mean if you're writing Haskell or TypeScript or something, you are operating within a host language. You are not writing a language. A language is hosting you. Okay? And number three, the solution is multi-phase development. We're going to get into that in a moment. What is power? Power was best described for me by an old colleague who said that power in the terms of programming is not operating at a high level or a low level. Power is the ability to move to the appropriate level. If you are in a high level language that does not provide you access to the low level, you have diminished power. You have high level things but not low level things. If you're in a low level language that does not provide you access to rich abstraction, then you are also lacking power. You are trapped at this low level where you are not able to generalize. And so power is the ability to move between them, right? Well, there's a couple axes here. There's high level, things like, maybe Haskell or Java, these types of things. And then there's low level, which are things like maybe C and assembly, right? But there's another axis that I've sort of become aware of here in the design space, and it's compilers versus applications. This is another axis of power. This is the linguistic axis of power, right? If you are in application space, this is kind of equivalent to being low level. And if you're in the compiler space, that's kind of equivalent to being higher level. You're more general across things, right? So what do we do about this? What we want is application generation. This appears to be a general thrust. And I think you guys can agree with that. Can we all agree that application generation is something that the market is thirsting for? And also something that I think a lot of us have tried to do in our own applications. I don't think I'm alone in having this experience of trying to iterate and iterate and iterate to the point where I can just sort of define the domain objects of my system and not have to do all the plumbing. Right? This is a kind of a common desire. So application generation is fundamentally the automation of every application layer. That's another way of looking at the same thing we're trying to do. We're trying to generate an app. We're also trying to automate all of the different parts of the app, all of the different layers. And so there's some prior art here we can take a look at. One is model-driven architecture. Model-driven architectures, have you guys worked with these? Oh, okay. So typically you specify your model somehow, and your architecture comes out of that. And there's kind of a reason this approach, it's a nice approach, but it didn't achieve like broad dominance. And part of the reason for that is that we are still living within our host language. We are limited in power, right? The automation capabilities are defined by the capabilities of the host language. There's a lot of these. There's domain-driven design. Domain-driven design is another example of kind of this general thrust towards we want to specify the domain and not do much else. We only want to write the things that are kind of unique to our application and not do so much plumbing all the time, right? There's also isomorphic programming. By this I mean when we're sharing the same language across different layers of the app, right? So one of the extremes of this is something like mean stack, which is well named because it's mean. But we have JavaScript at the database layer, we have JavaScript at the server layer, we have JavaScript at the UI layer, and so we can share code across all of these layers. And this allows us to automate parts of the application creation process. Right? There's also metaprogramming. Metaprogramming is a way that we can do code generation. Right? When we're doing metaprogramming, to some degree, we're kind of, once again, limited by the facilities of our host language, and we don't get access to the full capabilities of being a compiler. Right? And metaprogramming has a lot of different forms in which we can do this. Typically, when I see people, including myself, move in this direction where we're writing an application and we would like to derive as much of the plumbing as possible, it ends up being metaprogramming, even if you're in a very, very capable language. It's not always the case, but it's some form of metaprogramming. So metaprogramming, macros. So macros is one form. We've got templates. It's another form of metaprogramming. We've also got generics. I don't know how many people in here have done like a generic SOP, right? Generics programming in GHC, this thing where we have sums and products, and we can work that way. There's also time class inductive programming, which is something like a servant, where we describe some part of our application as a type, and then we use type class inductions to interpret that type into terms that we can then, then become our program. It's just another form of metaprogramming. It's just type-based metaprogramming instead of macro-based metaprogramming or templates. We also have things like free monads. You guys used free monads? Someone's guilty. Okay. With free monads, we end up doing the same kind of a thing. We end up describing like a DSL of our application as what they call a command functor, and then we are interpreting that functor into our program or into more than one program, right? But it's still basically the same overall concept. And then we, of course, have vibe coding, which is the new thing where we attempt to one-shot our application entirely, right? We take this thing of English prose and we give it to an AI, and the AI goes, well, I'm trapped within this host language ecosystem thing, and I'm going to blork out lots and lots and lots of React code that represents our app, but again, it's one-shotting. So when we do that, we end up with a new app each time we generate. Right? There's kind of no migration pathway. We're talking about committing as well. Like if you're using Copilot or something, we're talking about committing this code to the repo after it's been generated and living with it. Or we have to live with that maintenance burden. We still have to deal with it as people. The AI does not do everything for us. Right? But still, these are all sort of examples showing, I kind of feel like we're driving at the same basic thing. We want to generate our app. We do not want to spend all of our time, and we spend, according to some studies, as much as 80% of our time as programmers doing plumbing. We're not writing the business logic. We're not writing things specific to our app. We're just taking this bit of data from over here and writing a bunch of code that hoopty-hoops it until it gets to the user. Right? We don't want to do that. That's, I think, the thrust of why we want this. All right, so automation is limited. There's some other things here that are about automating different parts of the application. Like I said, application generation is best thought of not as, oh, I have some English prose and I'm going to use Lovable and Jippity and these things and I'm going to blork out a lot of code. No, we're trying to automate every layer. So there's some things that already work for this, right? Object relational mappers automate one layer of our application, right? Protocol buffers. This is another one that automates kind of one layer, right? It allows us to do code generation. Code generation and compilation are essentially the same thing, right? The protocol buffers give us a messaging schema, and then we can have one layer, which is the messaging layer, sort of automated and abstracted away from us to some degree, right? Things like Swagger. Swagger is another attempt to do this, right? Where we're going to code generate at the boundary so that we don't have to worry about this bit. Some of the plumbing is handled for us, right? There's serverless platforms. There's another variety of automation as far as I'm concerned. We're trying to automate away the entire backend, right? We've noticed that we know what a backend is, and this is actually something that's really important that I feel like is missing right now in the conversation is in the current year, everybody, we know what an application is. We have more knowledge about the structures that we're working with and what we're trying to build than we did 50 years ago. And the whole notion of like truly general purpose programming is sort of failing us because we used it to determine what applications are, what's useful, and then we stopped. And so we're still doing it in a general purpose way, which is part of why we're writing all of this damn plumbing, right? So we can automate a lot already, but not everything. Why? I'm suggesting that's the paradox. The paradox is this tension between compiler development and application development. So all of these approaches with the code generation, serverless platform, Swagger, protocol buffers, all of these things, type class inductions, these approaches always yield an EDSL interpreter in the user space of a host language. Is that a fair statement? How many of us have been there? There we go. Like it's not even that uncommon of an experience. All right. So a compiler inside our application. Does this ever work out? No, it doesn't. There's a reason this doesn't work out. It is an unbelievable amount of work to, within your host language, write some kind of a templating system that can handle all potential domain types and actually derive something useful from it. Well, I mean, it happens sometimes for a handful of engineers willing to work this out for each application independently typed language. There is at least this space where it sort of works out for people. But nevertheless, once you get there, you are, as my friend Tim would say, we write the greatest tools for dozens of us. So we end up with this very nice, elegant structure with an R app, where we have an EDSL for R app, which we interpret into R app, and is completely non-portable and not shareable, and also you have to have like 15 years of experience before you can even look at this code and squint hard enough and your brain starts to fry, and then you go, okay, well, I have no idea how I would extend the system. All right, so now I'm going to introduce what I hope is at least an interesting solution to this. So this is Paradox. Paradox is a programming language I've been working on for about 6 months. It is extremely nascent. It is not ready for prime time in any way, but it's a proof of concept by which I hope to sort of demonstrate where I think this thought should go. And this ties all the way back to my talk from last year with types are not safe, right? We have this need for something higher level, and when we're talking about this domain that we want to generate our app from, it turns out when I went to look for this, there is not a language that provides those facilities. It simply does not exist today. There is no language that provides this. We have things like protocol buffers and UML and the stuff which kind of approach, or even like SQL, you can derive a lot from that because it has things like constraint checking. But there isn't something here that's kind of friendly that we can use to go, okay, well, I've specified my domain, and now I don't want to write my app. What I want to do is I want to write something which will become a framework for which I can write my app. And I can do that in kind of a sane way. So Paradox is a domain specification language. I could not think of a better acronym. If you think of one, please let me know, because calling it a DSL is horrible. It's rich, it's typed, it's purely functional, and it's designed for transpilation. So that means that from day one, the goal here is not to become a real programming language. No I/O is permitted. We have functions, but no I/O is permitted of any kind. Right? Everything is necessarily pure. The idea is that you don't do that. What you do is you transpile it to something that you actually want to work in. And part of the goal here, and something that I was sort of feeling from actually the keynote earlier, is this notion that, what is motivating us for writing the software? And for a lot of us, it's not entirely financial. There's something that's just of interest here. But I would sort of suggest that this community of people, specifically here, is sort of uniquely capable of writing awesome tools. And instead of doing that in order to be helpful to the industry at large, we largely write them for us. And we write them in a way that we can't share. And there's something to me that's a little dark about that. And so part of the goal here is that the target market of this particular piece of Haskell code is not Haskellers. Because that would be an enormous waste of time. Okay. So let's take a look at some actual code, shall we? So what I've done here is I kind of pre-prepared this folder with Paradox in it. And this has never been demoed before, and so we are going to see if I can't live code something in this system in front of you all without it breaking or going absolutely off the rails. All right, so in here I've got more or less an empty folder. I've got some boilerplate stuff that I put in. We've got node modules because we are in fact a TypeScript application because I'm a TypeScript engineer as a user. And we've got a Nix flake because that's the only way I can survive. Okay. So the first thing we're going to do here is we're going to make a file types.docs, and we're going to start putting together a little app. So in here I'm going to say sando, say sandwich, and it's got cheese, and it's got bread, and it's got a name. All right, so let's just leave it with cheese and bread for now. It'd be a very simple one. Okay, and so you'll notice we actually have a language server. I was feeling like this is supposed to be a tool that people would want to use, so language server was actually the first feature that we put together here. But we have products and unions, so we can add a union here. Okay. All right, and so that is a paradox application. We have a specification of our domain, which at the moment is sandos, which have cheese and bread. They are just grilled cheeses. Okay. And so now we want to do something with this, right? So the first thing I'm going to demonstrate here is we can say paradox generate. And some things happened. So what happened? Well, we actually have dependencies here. So that's where some of those are coming from. Those are the two dependencies we have currently hooked up. And so we can take a look at kind of what happened. So under types, we have this TypeScript file was generated, which hopefully is at least fairly readable to everyone. Okay. So let's do something more interesting, right? Like, okay, great. So we were able to generate some TypeScript from this. That's nifty, but not huge. So we're going to also add another file, main.docs, where we can do a main statement. You'll notice how similar that looks to what we just typed. That is because main statements in Paradox are literally bash, which means that anything that you type here, you could run as a bash command a la carte. The advantage of doing it this way is that it is type checked. So you get the ability to do things that you'll see in a moment. But the next thing we want to do, so after we generate our TypeScript code initially, we're going to invoke the Paradox node, which is a Node.js framework that is written in transpilation from Paradox types. Right? So it is parameterized on the entire universe of potential types you could define in Paradox, which I think is kind of a cool thing. So let's see. In here we need to give it a port. And we need to give it a title. And this is going to be Tasty Co. Give it a footer. Okay. All right, and so that's all well and good, but we don't expect anything interesting to happen here yet. All right, so I'm going to go over here and I'm going to add another line in this. CRUD. I'm going to go ahead and pass sando as the argument. And we do actually have, like I said, this is nice. We can have some little hovers and things. All right, so there we go. We've got a little thing there. And so let's give it a go. Okay. Let's see. And then we have a working app. Welcome to Tasty Co. We have sandos. I'm going to make a sando. It's going to be cheddar. No, I don't like that. I want mozz and rye. We have a list view. We can go in here. We can delete things. We can change stuff up. And we have a working app. And I want to be clear that all the code we wrote is this. Yay! All right, well, that's all well and good, and some people have asked me if there's AI involved or something. There is not. The point here is not to do that. But that's kind of basic so far. So let's add some more things. Let's make it a bit richer. All right. So the next thing I want to do here is I would like to have a user. I'd like to have users in my system. Let's make that happen. So type user. And users are going to have name. They're going to have an email. Unfortunately, I don't have, there will be email types in these things in the standard library at some point, but they're not there yet. And we also have a password. Okay. So we've added our user, and you know what? I want to, and this is the part that will call back to my previous talk. We want to have some invariance enforced on our user. So we can do a valid statement for user and say the name is not empty. Name must not be empty. Okay. And all right, I think that's probably a good place to start. Now we need to inform Paradox Node that we have a user, right? Because it's not magic. It's not going to just notice, so we have to tell it. So I'm going to say account user. So that's kind of saying Paradox Node has this concept of an account, and we're telling it that the user type is the one we want to use for account. Okay, so let's give that a go. So we'll refresh this guy. And behold, a user account system has emerged from Vapor. And we can register. Okay, pretty sweet. We're able to log in successfully. But you can see it's kind of ugly, right? Like, welcome to Tasty Co, and then it's got this kind of ugliness here. And so let's address that. So that's no good. And we do that in Paradox with a concept called an illumination. Okay, so this part of this is just noticing in my career that there are these patterns that we need to generate the application with. We need the ability to say, hey, this is how we show this succinctly, right? Maybe we don't want to show the password, these kinds of things. So these language constructs are kind of based upon what we actually need to provide sufficient richness to be a domain specification language, which has been sort of an iterative design process on my part. So we've got that, and then you know what? Let's do some more things. Let's, in addition to that, add role-based permissions. Who thinks that's going to work in the demo out of the box? All right. So in order to do role-based permissions, we need to import the standard library, and we need to import the node library. Okay. And the node library contains a type CRUD, which has CRUD operations in it. Okay? So now in here, I need to say we're going to have a new union, role, and role is going to have 2 bits. 1 bit is going to be admin. Let's say the other bit is going to be operator. Okay. And now I need to provide a matrix. So I haven't shown you any variables yet, but we do have them. They're not as needed as you might think in some cases. So I'm going to say permissions, and permissions takes a type and a role, and we're going to get back from that a set of CRUD. Okay, and so the first type we're going to have is Sando. Actually, here. You know what? I'm going to use my prepared example, because getting this right from memory is going to be tough. Okay. All right, so this is a prepared example I have in the repo that you all can check out when I publish this, where this is a pet shop. And so this is a little bit more fleshed out. So here we import from the standard library, we've got species, we've got pets. Pets have some constraints placed upon them, right? It's got to have a name. We can also say age needs to be, let's say, greater than 1. Okay. We've got our user type. Our user type here is a bit more explicit. Our illumination is also a little more interesting. We do first name, last name, right? We've got our role, and then down here is our matrix. Okay, and let's add something to it, right? Let's say we want to have user as a type here. We want to say admins can do all of the CRUD operations. That is a set universe. That's how that's described. That would, if you have a set of a type that is also small and enumerable, then you're allowed to use this notation to say everything. Also, if you have a set which is of a type which is small and enumerable, it is therefore also a bit mask, and so and or will also work. Okay, so we're going to say users. Can operators, let's say operators can read users and that's it. They can't update them at all, and customers can't do anything with them. Okay, cool? So far so good? All right, so here is our little thing it's a little more complete here, and you can see it, like, because it is just bash, we're allowed to do things like this. So I'm adding a vite for the front end, right? And that works here. So this is UI.ts, and we can just, because our TypeScript is generated, we can just import whatever we want. Here I'm importing the node library that was written in docs directly into TypeScript here, and I really don't want that to be alert, so I'm going to say console.info. A little more subtle. All right. Okay, and so we can see we got even our Vite build was successful in there. All right, so here we go. Let's register. I'm a 12-year-old. And we can have a role. So there, this is to demonstrate that those validation statements do actually work. So, and that is a runtime validation. And because it's written in Paradox, we can share this validation logic between the front end for form validation live in the browser, the API layer. We can also generate our SQL with this validation in it as a constraint check in Postgres. Right? These are the kinds of things that we want to share. We kind of know what we want to share and what we want to automate. Right? Things like I want to validate this, I want to be able to humanize this string, I want to illuminate it so that it can be seen by a human user in a way that they can disambiguate between objects. Right? These kinds of things. So that didn't work, so let's make a valid user, because I am not 12. I'm actually 19. Ooh, what did I do wrong?
You typed 1232 when you created the password.
1232, I screwed it up. I did, and I screwed it up in the way that you said. Thank you, sir. All right, so here we've got this, and I can make a pet, Mittens, 12-year-old cat. Okay, so I'm going to log out and make a new user. And this person is going to be an operator, which gives them different permissions. Okay. I can see the pet. I can try to delete the pet. Permission denied. So there we go. We have role-based permissions and a working application. And what we've written to achieve that are just the following files. We've got main. We've got our types, and we did UI, TS, and a handful of little things. And that's it. This is all we had to do. Hopefully you guys find this somewhat compelling. So we all pass permissions, and we can have this, and all we've done is specify the domain. Mr. Dysinger.
I don't want my app to look like that, so what do I do now?
It's just locked. I told you, it's a one-shot. Okay, so it's not a one-shot. So yeah, we don't want our app to look like this. We want to be able to extend it now, right? So I've shown you kind of how we can do generation, but we don't want that. One of the major things we don't like about application generators and AI and this stuff is that we cede all our control, right? So how do we extend this, right? So one way that we can extend this is I have a file here under the folder pet called update.ts. And update.ts, this is a sort of Rails-style extension mechanism by directory structure. Okay? So because we have a domain object pet, and because update is one of the known operations from the CRUD server, we can have this update.ts. And update.ts, we can import pet from our paradox types, because it is in fact generating the TypeScript. We can import store. Store is our backend storage, which right now is an in-memory store, but won't be past it being a proof of concept. And then in here, we can do stuff. Like, for example, I can specify that cats don't change. You're not allowed to change cats. If the species is a cat, we're not going to change the record, right? And so that gives us a way to extend the API layer. Sorry, it's now a bunch of work to get back in here because I have to create an account. Maybe you'll just believe me. So I'm going to attempt to change mittens. Mittens is now 13. Cats don't change. So part of the idea here is that because we can use this kind of Rails style by convention, you put the file in the right place and it works. This allows us to do our application development at a different phase. So Paradox node represents one phase. It's a generation phase, and you can write your own of those rather readily. The next phase is the runtime phase, where we can write our application. And so we now have a multi-phase development structure, where we can say, I want to write things that are about all potential domain types, and then I want to write things that are about my specific app. Right? By doing this, I could, for example, wire in whatever dependencies I like. I can pull in the Stripe library for TypeScript or whatever else I want, and I can just kind of write those endpoints by hand in a language that I'm familiar with without having to go back to Paradox. So it's extensible in this way, right? And this mentality of by file structure, we can override literally everything that has been code generated in here. So another thing we can do is here in user create, I have pug. Pug is what we're using for templating because it's the default Node.js HTML templating library. Thank you to the Holloway Chuck. And here we've overridden the isAdmin part of a field when we're creating a user. And we're not creating users right now, so let's fix that as well. And we should be able to see this in practice. Okay, so I added a second CRUD line. Now we can CRUD two domain types, right? And one of them is a user, and this guy is in a folder user/create isAdmin.pug, right? And so for that to actually be effective in some way, we also, I think, need to have something like that on the user type. And we don't. Okay. And so just to show that this is really what's happening here, I'm going to put in we're just going to get rid of the input element. Okay? All right. Let's see what application that made. Okay. Here's isAdmin. You'll notice it did not show up there. It's because there's a distinction between registration and creation. Also, you can see the illumination working here. It's giving us first name plus last name. I know I didn't put much good in there, but you can see it does work. It's not quite as ugly. But by adding the CRUD line, we can now CRUD users. And I can create a user. And you can see it overrid the appropriate component of the structure. And so in this way, you can go as limited as I want to override one form field, all the way through I want to just have my own UI completely. Right? You can completely ignore what's there. What is provided to you, whether you like it or not, is the APIs needed to make this UI. So you were always given a context where you have something called an item in your hand if you're on a singular view, where you can iterate over the keys of that because it's a JavaScript structure, right? If you have a list, then you're going to have a list of these things as an array. So these facilities are given to you regardless. And it's your job to kind of choose how you want to extend the system. The last bit there, which you remember before, is that I did have a Vite build going on, and so we should be able to see that as well under the console. Do we? I don't think we do. I think I have a bug. No, it is working. So there we go. Paradox running on port 3000 in the console is showing that we were able to, in the same very kind of limited amount of code way, have a TypeScript file for the UI. That TypeScript file has access to everything that Paradox provided, right? So all of your types, as well as all the types from all the dependencies that could be in there, as well as any functions and terms that would be in there. And it's able to hook up all the way through, and we can have it on the front end. So this also works with CSS and all of that. So that's it. That's kind of my little demo to show how this might work out. Any questions?
We just defined terms like CRUD. We use the term CRUD, which did a whole bunch of stuff.
Yeah.
Is it something baked in, or like there's some special points also to define CRUD?
I'll show you the code. Let's just do that. Okay, so we have this in here. So we've got multiple executables in this project. This one is the node server. And so node server takes in, it's got a opt parse applicative for settings. You can see there, that's the settings that you pass it on the command line. And we have some functionality here to connect the Paradox language to what command line options you're passing, right? So you can reasonably pass types. That's why we have like a maybe type identifier. Type identifier is a Paradox concept, right? In the settings there, and then over here, this is the actual code generator for the node server, and it's let's see, it's about 530 lines. So all of the functionality you saw there was as terms of the actual server logic, was code generated in under 600 lines of code that mostly just kind of looks like this. And there you go.
So the docs code remains the same,
Mm-hmm.
but you would write different generators.
Yes.
Maybe you could show that JSON and YAML for a second.
Oh, sure. So I just recently added support for this. So let's see. Can't remember how to find the command. There we go. All right, so here in example docs, so I'll show you that file real quick so you can see there's nothing up my sleeve. All right, in here we've got this is a little sandbox that I maintain just so I can play with the language and see what's going on. So actually here's a function. Jello country is a function. But we also have a literal here. So Chloe is a literal of this person type up here. Right, and you can see there's a little bit of evaluation going on. So true and false is obviously always going to be false, but this is still helpful to see that we're actually generating it. We can use functions to generate, so this makes us a competitor for something like doll as well. And when I run this command, we need to tell it what variable we want to turn into YAML, and it needs to be an appropriate variable type. Not all variables can be turned into YAML, but Chloe can, because it's a product type literal. And we're going to out that to Chloe from that file. And here we can see that. works out. We can also generate more things. We can generate JSON, and because that main statement is literally just a bash runner, it's very easy to kind of interleave your own stuff. So part of the idea here is that, like, I've written a few generators for you, with YAML and JSON. There's a fairly mature generator for generating TypeScript code. We've got tests against that evaluate it against a canonical representation of the evaluation. There's also a Haskell code generator, so you can generate Haskell code with this very readily as well. Part of the idea here is that we would have eventually some kind of an open source ecosystem of generators, where Paradox Node, which I've demonstrated today, as a generator that provides facilities to go from Paradox types to a working web app with this particular idiomatic kind of framework schema with the file system. You can write your own. You can write your own generator to generate a different type of an application, or one that's bespoke to only generate your application. But the advantage here is that we resolve the paradox. We're no longer dealing with this limitation and tension. We're no longer going, oh, my host language metaprogramming facilities are what I need to do, and I'm going to have this ever more difficult tower of macros to understand. No, instead, I have a rich domain specification language. I parse and type check that into an AST that's very nice and well laid out for me, and then I just write a term level generator for whatever it is I want to generate. And that gives you the first phase, and because you're able to generate whatever you want to generate, I would suggest it would be nice if most of the time you generate something along the lines of a framework that's extensible, which is what I've demonstrated here. But it's entirely not necessary. You could use this for all kinds of different things. But that's it. Any other questions?
So once you have data in this system, if you go back and change one of the types, will it generate migrations for you? Or like, what is the persistence of the data there?
Like I said, what you're seeing here is a proof of concept. So the current data storage is in memory. It is just in memory. However, I already have the SQL bit going for this. The idea is that we would have a SQL generator that will store. What we're going to do is we're going to store the previous paradox expression, right? Like as an array of paradox expressions that generate the SQL, and then we can do a diff between the current paradox expression and the previous one representing the current database state, and give you a migration for free, and give you a migration that is destructiveness aware. So it will tell you, hey, by the way, you're about to delete some things, are you sure? This is a destructive migration versus a non-destructive migration. So yeah, that's exactly the idea. The idea is that we actually can generate all of it. We actually can automate every damn layer. I hope that I've at least to some degree proven that point. We can automate every layer of our application building process. We can have surgical additions to that allow us to provide only what's unique to our app. And we can do all of this while not committing unbelievably large reams of ayahuasca to the code base.
Okay, I actually have a follow-on to that. Do you see a trade-off with the underlying tools you're targeting, like SQL or whatever, and being able to automate it? Do you have to be opinionated about what the things you're eventually going to be targeting are in order to actually automate it? Or do you think you can actually have it fully automated and fully flexible at the lower levels?
I believe it can be pretty close to fully automated and fully flexible at the lower levels. However, there's no need to do that. For example, when I generate a YAML file, I am necessarily not generating my functions. Right? If I have functions in my code, I'm not generating that. I have to tell it specifically what variable I want to generate, and that's all that it's capable of. For something like TypeScript, it can generate more, right? Everything in there can become, everything in there can become Haskell. Everything in there can become Go. But not everything can become JSON. So the mentality to operate with is I'm going to provide as much as I can in my target language as is kind of reasonably possible. And it turns out that's not just enough. It's typically way more than enough. You get more than you actually need with that. But yeah, I don't see any reason why we can't have a Go backend for this, a Python backend for this. Not only that, because we can generate config with it as well, you can have like a single source of truth by which you're saying, here's what's there. Paradox can have dependencies, so I can say, all right, well, I'm going to pull in these paradox types that are related to my generator, or related to his generator or her generator that I'm pulling in, and I'm using those types. And I can even say, okay, well, here's the port for this. So now, let's say we write a Nix backend, right? Now you could potentially be generating your infrastructure from Paradox as well, where you have one language that describes the domain of your application, refinement types which is basically what a validation statement is at runtime, as well as you could potentially describe the infrastructure and other things. Any other questions? We have 5 minutes.
So if I understand correctly, once there are more generators involved,
Yes.
I just add those to my main if I wanted more code generated in different ways.
Yes.
Well, if I was pick the stack that was like, Node and Postgres, and I would pick those generators and configure them in that main, and I could even configure my YAML and whatnot that was generated in there as well.
That's right. As well as it doesn't have to be one of ours. Like you saw, I put in an npx command. Like that's Vite. Vite is also a code generator. That's what it is. But yeah, you can continue to kind of layer and build things up that way if you wanted to. Like one other thing that I was sort of musing about that would be a nice one to write would be a generator to do temporal I/O things, and then you could have like a deploy to durable computing in an interesting way. You could have these kind of long-running tasks interlaced with each other. That should be entirely possible. Okay, yeah?
You mentioned that you don't support I/O, that's pure functions.
Correct.
Is the I/O handled then on the language layer, or where's the
Yeah, correct. The purpose of Paradox is not to be a programming language in which you are doing I/O and writing your app. Its intention is to be a domain specification language. So I would suggest that if what you're trying to do is share a function, like some portion of algorithm between different languages or layers of your stack, which is what that would be for, that is actually much better to be enforced as pure. Right? So the actual I/O stuff you do at the application layer. It's multi-phase development. Application layer is where you can take advantage of existing tools, languages you're familiar with, libraries that are popular in those ecosystems, these kinds of things, while still getting the benefit of automating away almost the entire core of your application away from you completely. Any others? We got just a few. Yeah.
Seeing as I/O isn't possible, is there some way to Is there some way to parameterize your Paradox files so that, for example, if you wanted in, say you want to have two stacks that are identical except one's prod and one's gamma, but then in gamma you want to track some additional information on users for debugging purposes.
Sure.
Is there a way to parameterize your file so that you can not have to duplicate all the code involved?
No. What I would probably do in that use case is I would provide a union to represent my environments, a union type. And then I would have maybe more than one main docs file that calls different arguments, right? So I might, instead of having main.docs, I might have staging.docs, something like that.
Okay, that makes sense.
Yeah. Like I said, we also do have functions. So you are allowed to have like a function that would, for example, take in as an argument this environment type enumeration and then produce some value in response to that would give you that same kind of parameterized quality. Any other questions? What do you guys think? Do you like this idea? Is this exciting? Is there something here? This has been a lot of thinking put into this. I'd like some feedback. So that's why I'm doing the talk. I'm trying to elicit responses.
So like SQL was developed. Sorry, I'm trying to talk loud because I didn't have a mic. But so SQL was originally developed for business people. But nobody ended up using it, and only computer programmers used it. So, are people really going to understand what a matrix is? And I don't know. To me, it seems simple. It's like a spreadsheet, but
No, I do understand that the goal here is not to support us, right? The goal here is to try and support programming more broadly, which is why the first target I took seriously was TypeScript, once I got Haskell done because I needed Haskell for my sanity. That's part of why the notation is as it is, right? The notation is kind of modeled after something like YAML. And this is also why I did things like put a language server in there from the get-go, right? Is that this is intended to be a tool. And so one of the other potential advantages here is that this your paradox specification serves as a knowledge graph in some ways, right? It has knowledge of what dependencies are being used. It has knowledge that these are domain objects. It knows these types of things. So like as the language server also needs to expose this knowledge graph, right? We need to be able to query particular points in the code and say, hey, what is this thing? You know, this is a field. It's a field. It's user.email and it has type text, right? But this is sort of more where I'm hoping things like AI will be helpful to paradox developers. Is that we're not using AI to blork out enormous amounts of code or trying to one-shot an application or using domain-driven design tools which are restricted by the host language, right? But rather we can ship this knowledge graph of knowledge about the domain of the application to an AI that could then answer questions about your app for you that could be really rich. Like for example, imagine you got a runtime exception in staging, right? And the runtime, and you want to know what happened. Well, a system with these types of powers should be able to do things like have knowledge of the Git tree within its context window, have specific knowledge of the application structure from the domain specification within the context window, and be able to tell you things like, this was fired, the error came from here, that file was generated by this plugin relative to this data structure, which has these properties and this semantic meaning to the plugin. It is in fact an account, right? And this change was made at this time by this engineer, right? And it was deployed then. And so we can actually know all of that and get like an English prose response that could be helpful. That's kind of where I'm seeing potential value for things like that. Because right now it'd be very difficult to produce that even with like a lot of good AI and a massive context window over the code, just because the code doesn't document this, right? It doesn't. Nowhere in your code is actually documented the domain of your application and how it interrelates. That's a problem in my mind. Yeah?
All right, next up is lunch. Let's get a
All
round
right.
of applause for Isaac.